Hey guys, what's going on? So in this video, I wanted to go over some problems we didn't really have enough time to go over today in class, as promised. So these problems are going to be from both of the classes, intermediate and advanced, and from both modules. So I don't really know which modules are which because the test that I was looking at doesn't really tell which modules they're from. So these problems will just be kind of a mix of both. So starting with the first one, we have a definition of the function f of x, and then we're told that h of x is f of x minus 4. So what that means is that we're going to take f of x and just replace x with x minus 4. And then think about what this function could possibly simplify to. So we have to remember our properties of exponents. 2 to the a minus b is the same as 2 to the a over 2 to the b. And that's what we're going to use in this scenario. So this is going to be 272, 2 to the x over 2 to the fourth power, which is 16. So we have 272 divided by 16. That gets us 17. So the answer is 17 times 2 to the x power, and then that is our answer. All right, so in this problem, we have a complex polygon, and then we know that we have two parallel segments. And then we have angle B is 130, and then we know that angle D is 174. And then we're trying to find the measure of angle C, which is right here. So normally we might be tempted to think, well, it's a polygon, it's a pentagon. So the angles would all add up to 540. So that's actually not the approach we want to use in this situation. We want to make a line right here, and then we want to figure out the angles formed by angle B for the exterior, and then also by D's exterior as well. So notice how we have a bunch of linear pairs. 174 plus x is 180, so then this has to be 6. And then for the same reason, um, oh, whoops, it has to be 139 for this angle. So if this is 139, its supplement has to be 41. And then if this angle is 41, this one down here is also 41 because we have alternate interior angles. And then this one is also 6 for the same reason. So angle C is just 41 plus 6, so it's 47. So in this problem, we have a radical equation has one real solution. And then we want to find the minimum value of 4k so that this holds true. So you can do this with Desmos, but I want to show you guys how to do it without Desmos. So we want to find the discriminant because we know if the discriminant's 0, we only have one real solution, and that's what we're after. So what I did is I squared both sides. And then I did a little bit of simplifying. So I FOILed this out, and then I zeroed it out. So I made this equal to 0. And when you do that, you're going to end up with this. So the discriminant is b squared minus 4ac. And we already have everything we need for that. So b is negative 115. C is all of this. So C is a 3,364 minus K. And then A is just 1. So if we plug all of those into the formula, we end up with this. So we want the discriminant to be equal to 0. And then when we do that, we end up with negative 231 plus 4K equals 0. So then 4K has to be 231. And that is the answer. So for this problem, we have a polynomial, and we know x minus k is a factor. So then if x minus k is a factor, what that really means is that it's going to make this equal to 0, which means k has to be equal to x. So if we plug in an x for k in the equation instead of equal to 0, this is what we get. K is x, so k squared is x squared. And then we want to solve it for x. So if we add x squared to both sides, this is what we get. So we're actually solving for n, not x. My bad. X squareds cancel. So then we end up with n equals 29, and that is the answer. So for this problem, we have to use a little bit of physics knowledge. So we know that speed is distance over time. Like miles per hour would be miles over hours. So that's the reason why that works. So we know that for object R, we know that object R has half the speed that object S has. So R's speed is half the speed of S. And then we also know that, whoops. So we also know that the speed of R is R's distance over the time it takes to travel. And then the same, whoops, sorry, time it takes R to travel. And then the same goes for object S. So object S, it's the time it takes object S to travel. So what we want to do from here is we want to set up kind of a system of equations and kind of equate everything together as good as we can. So then we know that we have these two things are the same, which means these two also have to be the same. So we have distance of R over time of R is equal to 1/2 the speed of S, which is the same as 1/2 of all of this, 1/2 of that quantity. And then from there, we can cut out the middleman and plug in some values. So we know that R travels 4x inches. We know it travels in y seconds. And then we know we have distance object S travels is 24x. And then this is what we're trying to find. We're trying to find t. So this works out to be 12x over t. And if we take the reciprocal, this is what we get. And if we solve for t, we end up with t equals 3y, and that is the answer. So for this one, we have an alloy, which is just a combination of different metals or substances. So we know that we have a total mass of 50 grams, and it's made up of two different pieces, each with their own different grams and their own different silicone concentration. So the first one we know is 30% silicone. And then the second one is 80% silicone. So we don't really know their masses, so I'm just going to call the mass of the first one X, and then the mass of the second one Y. So their masses add up to 50. And if we want to talk about silicone alone, then we know that we have 30% of X is silicone. And then 80% of Y is also silicone. And then that's going to give us a total of, well, I forgot to write part of this. We know that it's, oh, actually, yeah, I did forget to write something. So the problem specifies that the alloy sample is 50% silicone in total. So what that means is that if the total is 50, we have 25 grams of silicone. So the silicone in the first plus the silicone in the second gets us 25. So we have the top equation and this new one that we need to work out. So you can just use Desmos to get the solution to the system. Just type this in the first line and then type this in the second line. So once we do that, we're going to end up with y equals 20. So that means we have 20 grams altogether in the second sample. And if we want to find the silicone concentration, we need to do 80% of that quantity. And we get 16 for that. So the second one is made up of 16 grams of silicone. All right, hope you guys found this helpful and good luck.